Right, so in question 1 we've got a tennis ball that's been thrown up vertically into the air. It starts off at position C and it goes up to reach a maximum position of A. So we're given a bit of information which we're going to use later on, but the first thing we've got to do is to write down the equation for kinetic energy that involves mass and speed. Okay, so we can write this in words. So kinetic energy is equal to, and it's 1/2 times mass times speed squared, and it's also fine to write it with symbols. So E for energy, a little k there for kinetic, 1/2, m for mass, and for speed we use a v, so 1/2 mv squared. Moving on to the second part of the question, we've now got to use that equation to calculate the kinetic energy of the tennis ball. So remember what we had there was 1/2 mass times speed squared. So 1/2 mass speed squared, and now all we need to do is to substitute in what we had before. So 0.5 is 1/2, the mass of the ball was 0.058 kilograms, and the speed it left the hand with was 5 meters per second. So we are going to do all of that. Now there's no compulsion on you to use your brain to do that. If you've got a calculator, just go ahead and use your calculator. So working backwards, 5 squared is 25 times 0.058 times 0.5. When you've put that through your calculator, you should come out with 0.725 joules. So that can go straight into there, into the answer box. And then the next part of the question, we're told that position A is the maximum height of the tennis ball, and we're asked what is the gravitational potential energy. Okay, and we can also ignore the effect of air resistance. Right, so normally if we were going to calculate gravitational potential energy, we'd be expecting someone to tell us the height, we'd be expecting someone to tell us how big gravity is and all of that information, but we haven't got that information. But what we do have is we've got the conservation of energy. So that ball started off with some kinetic energy at the bottom, and where that energy has gone, it's been transferred to the gravitational potential store. So if we're ignoring air resistance, then we can simply take the conservation of energy to say that that 0.725 joules of kinetic energy must become 0.725 joules of gravitational potential energy, and that's the reasoning for that. Okay, having done that piece of reasoning, we're now in a position to actually do a bit more. So position B, the tennis ball has 0.38 joules. Okay, so 0.38 joules, we're obviously somewhere between where it started and where it finished. Okay, and now we're asked for the equation. So we've got gravitational field strength, we can use the symbol G for that. Potential energy, we can use E subscript P for that. Height, H, and mass, M. So using all of that, we can say the gravitational potential energy is the mass times the gravitational field strength times the height. So it's absolutely fine to have that in symbols. It's also absolutely fine to write it out in words. It will just take slightly longer. Okay. And then what we need to do for the last part of this question is to calculate the height of the tennis ball above the player's hand when it's at position B. So position B, what we know from position B is, from up here, we know it has 0.38 joules of gravitational potential energy. So 0.38 must be equal to mass times gravitational field strength times height. Okay, lots of different ways of doing the substitution, but we know the mass of the ball is still 0.058. We're now been given a value for G, which is 9.8, and we still don't know what H is. That is a thing that we have got to work out. Okay, so knowing that, we can do a little bit of rearrangement so that H is equal to the energy, we had 0.38, and we need to divide that through by the mass and the gravitational field strength. Okay, and that will give us a value of about 0.67. Okay, so let's pop that into there as our final answer. And obviously what I've done there is I've rounded off the answer to just a couple of decimal places or significant figures, and where you've got a long decimal as your answer, we would expect you to round off to say 2 or 3 significant figures. Quite often the question will give you a number of significant figures to round off to. Alright, so that is how to do question 1.